Okay, this is for Math 210, the review for Test 2. I'm going to work backwards through the review test, the practice test, whatever you want to call it, the study guide, and I will present a few slides to kind of highlight the concept. So we're going to do 12.6 on elasticity first. So first to go through, we want to remember what the let's go with green. So we want to remember that the elasticity E is the percent decrease in demand, so that's a percentage, over the percentage increase in price. Now, as we work through problems, oftentimes they want us to compare what is the relationship between the demand and a 1% increase in price. So we got basically our ratio looks like this. When we're over 1, what the top is the decrease in demand, and that's simply the value of E. So they will give us the value of E, and they'll ask what percentage it is. Well, that's what it is. E is it. So we'll look at a few examples where that's all it is E is the percent decrease in demand. And it just is because that is the definition. We said it is, okay? So then they go through this steps here mathematically. What this gets us down to is the formula that we end up using for E, and we can characterize this in one of two ways. We could just say that this is the change of Q over the change in P. What that really is, it's the derivative of Q. And then it's times P over Q. And Q is going to be a formula, a function, an equation in terms of P. So that's why we also will write this as, instead of Q, we'll say Q is equal to some function of P, f of P. So it's minus the derivative times P over f of P. These are the same thing, just written in different forms. Whichever one that suits you better, you can use. Okay, so price elasticity of demand. So again, we've got the formula, the derivative, the negative of the derivative times P over Q. Or another way to phrase it, it's the derivative of the demand function. We write as f of P, right? F of P equals Q. Same type of thing here. So we can do it this way. But here's what we're going to be comparing. Once we do this calculation at a particular price, we get a value for E, the elasticity. If E is greater than 1, we call that elastic, and it means that an increase in the price causes a reduction in the revenue. It reduces the revenue because the demand drops faster than what we raise the price by. If it is inelastic, that means that E was less than 1, then an increase in price will actually increase the revenue, because E being less than 1, raise the price by 1%, the demand drops by less than 1%, so we actually get greater revenue. So what happens is, when we're looking to maximize things, that's why we go with unit elasticity. We're trying to get it equal to 1. When E equals 1, we maximize the revenue. Because notice, if we're inelastic, increasing the price increases the revenue. If we're above here, increasing the price reduces the revenue. So reducing the price increases the revenue till we get here. So notice both arrows are pointing towards what we're trying to do is get a maximum to our revenue, and that will do it. Okay, so we'll use these concepts to answer the questions. We'll use this definition or formula for E to be able to calculate various values of E and then determine whether that price is the best price or not, as far as trying to maximize revenue. And that's what this unit is all about. Okay, so let's look at this first one. And again, my numbers here are a little bit different than what they are on the review, because This I renumbered this. I'm only going 12.3, 12.5, and 12.6. So, but you'll match it. This is the first question in the section on 12.6. Okay, so first we're suppose the elasticity of demand is 3.2. That's what E equals. Okay, at a particular price, $25. What does this mean? It means the demand is it going up or down by what percent for 1% increase in price? Remember, when the price increases, demand will always go down. Again, except for maybe luxury goods, but we're not considering that. So the demand's going to go down, and by how much? By the exact value of E, 3.2%, for a 1% increase in price. So a small increase in price will result in what's going to happen to the revenue. The revenue is going to decrease because the demand goes down by more than the price went up. Net result is, remember, revenue is always equal to price times demand, which is our Q function. And so if price goes up by 1%, but the demand goes down by 3.2%, when you multiply them, you get less revenue. Okay. And again, I gave myself a lot of space here. It's going to go down by 3.2%, and revenue is going to decrease. So the three answers: down 3.2 and decrease. Down 3.2 and decrease. Okay. We'll apply these same concepts to this question. Again, same type of deal. Here we're told that the elasticity of demand, the E, is 0.65 at this price, at 500. So this means the demand will go down. Always the demand goes down when the price increases. A 1% increase in the price means it'll go down by how much? By the exact value of E, 0.65. And so, but in this case, this is inelasticity. And so a small increase in price will actually cause the revenue to increase. Because the price, remember, here's revenue, here's price, here's quantity. As the price goes up by 1%, the revenue only drops by 0.65%. So the net, when we multiply these two, is a net gain for the revenue. So we're going to increase the revenue whenever E is below 1. And again, we've got our answers here. The demand goes down by 0.65, but that does increase the revenue. Okay, so again, we just go back. It's really coming from here. Okay, so those concepts, understand them, memorize them, remember them by working through these, understanding the concepts. Okay, so we got now two problems we'll work through. We've got weekly sales, some backpacks is given by this formula here. And again, you could either just call it Q, or if you want to, you can rename it as F of P. Okay, and Q is the quantity, P is the price. Find the elasticity of demand at a price of $20. So elasticity of demand, remember, we're going to be using the derivative of the demand function. So the derivative of this function, derivative of 1080 is 0, derivative of minus 18p is negative 18. So let me click in here and give a little bit more room. Okay, now let's come back. So what we want, find the elasticity of demand for a price of $20. So first let's set up the formula. E is equal to minus the derivative of the demand function times P over the demand function. Okay, so we're going to say it's minus negative 18 times P over 1080 minus 18P. It's going to keep going in negative and negative, make a positive. 18 times P gives us 18P in the top. 1080 minus 18P in the bottom. So that's our function. What we now do is we plug in 20 for P. So we're looking sort of for the elasticity function at 20. And again, if you want, you could say this is really E of P. So we want 18 times 20 in the numerator. 1080 minus 18 times 20 in the denominator. 2 times 18 is 36. Put a 0 on it because of the 10 power, so 20 times 18 would be 360. This is 1080 minus 360. So we get 360. 1080 minus 360, that would be 720. And then I think you get 36 goes into 72 twice, so you get 1/2, which is 0.5. Okay, so that's the value of E. So now what can we say about that? That's our answer there. So is the demand at the price of 20, is it elastic, inelastic, or unit elastic? It is inelastic because it's less than 1. So we've got E is less than 1, making it inelastic. It means that if increasing the price by 1% will actually increase revenue. It doesn't change the demand enough. So we really want to raise the price, right? We need to raise the price from $20 so that the income, the revenue will increase. Okay. And again, it's just it's a comparison, and you just have to remember these. But a lot of times in mathematics, there's that 1 is at place. That's at least with exponential functions as well. Something above 1, you get increase. Something below 1, you get decrease. In this case, elasticity below 1 means we can increase the price and also increase the revenue. So what price will maximize the revenue? Well, what we're going to do is we're starting with this function we've come up with right here, 18p over 1080 minus 18p. And what we're going to do is it will maximize it. What will maximize this is having E equal 1. So we're going to look to have E equal 1. So that means that we take our formula, 18p over 1080 minus 18p, set that equal to 1. Now we can do some algebra on this. What I would do is I would cross multiply we can also use a graphing calculator, which I'll do in just a moment, or maybe I'll do that first, right? So you can cross multiply. What that gets us is 18p equals 1080 minus 18p. So we add 18p to both sides. That gives us 36p equals 1080. And then divide both sides by 36. So we get our final answer here that P is going to be 1080 divided by 36. Let's pull this one up. $30. So that is the premier price. That is the price that's so $30, a price of $30. Will maximize revenue. And so what is the maximum weekly revenue? Well, remember, revenue is always price times quantity sold. So if we use 30 as our price, P is 30. Q comes from the function here, 1080 minus 18P. So we multiply by, 1080 minus 18 times 30. That's going to give us our revenue. Okay, so that's, let's go up a little bit. Let's do this part first. So this is 1080, 18 times 3. So it's going to be 8 times 3 is 24. Carry the 2, 3, that's 54. 540. 1080 minus 540 happens to be 540. And then we multiply that times 30. So then we can notice we've got the 2 zeros, so that's going to go on the end. 3 times 54. 3 times 4 is 12. Carry the 1. 3 times 5 is 15, plus 1 is $16,200. Not bad for a week's revenue. Of course, that does not include the costs of making whatever we're making. So, but that is the revenue. And that's the maximum we're able to make with these functions, this demand function. And again, we come down here. Let's take away some of this so it sets a little bit better. There we go. We see our final answer, 1620. That's what we got. Excellent. We for the C part, we did get $30 was the maximum. Again, doing it by setting it equal to 1. And we, since our elasticity was 0.5 in the beginning, it's inelastic, so that makes sense. So hopefully this all worked out. Be able to do problems like this. Okay. Awesome. One more question, and then I'm going to end this video. We'll go on to the next one, 12.5. So similar type questions. Suppose this is our demand function. So we've got a quadratic here. Again, if you wanted the notation with function notation, we could call this f of p, the demand function, g of p, d of p, whatever you want. Okay, minus 2p squared plus 33p. So remember, since we want elasticity, we're also going to need the derivative. And I like to do these things in pieces. So let's take the derivative. We get 2 times 2. That's going to be negative 4p to the first power. Subtract 1 from the exponent, right? For this part, we get 33 as our derivative because 1 times 33 is 33. And then 1 minus 1 is 0, so that's p to the 0. So that's what happened to the p. So there's our derivative. Our elasticity, let's give a little bit more room here. Our elasticity is going to be E of P, or just E if you want, minus the derivative of the demand function times P divided by the demand function. Okay, so our derivative is here. So what we end up with, maybe I should put over here. Yeah, we'll be fine. I'll go minus 4p plus 33. That's the derivative. Times p, p is just p, over f of p, which is minus 2p squared plus 33p. Give a little bit more room. We're going to multiply the tops, but rather than distributing, what you could distribute, but I noticed down here each of the terms in the denominator have a p. I'm going to factor out that p, and it'll cancel with this, and it'll just simplify a little bit nicer. But before I go on, some of you may have been screaming at me here. I forgot my negative, right? So don't forget that negative. It's a part of the formula. So minus, minus. So as I do this, I'm going to distribute this negative through, and I'm going to rewrite this. Again, E of P equals here. So I'm going to come down a step. This will become positive 4P, and this will become a negative 33. I have to distribute that through. And then I'm going to leave this P on the backside. And then when I rewrite the bottom, I'm going to distribute out a P. So this is going to become minus 2P plus 33 with this P out here. It wouldn't be wrong to kind of leave this all, but they oftentimes want it in simplified or reduced version. So we're going to do that. We get our final answer. E of P is 4P minus 33 over negative 2P plus 33. Okay, find the elasticity of demand function. That's what we've got. E of P. Okay. So now let's go to the second part. Find the elasticity when P equals 15. So we're going to plug in 15 for P. And then we're going to answer some questions here. Okay, so what we need to find is E of 15. That's 4 times 15 minus 33 over negative 2 times 15 plus 33. 4 times 15 is 60 minus 33. 2 times 15 is 30, so it's minus 30 plus 33. There's a similar one we did in class today that I changed to 30 instead of 33, but I think I'm okay so far. So this 60 minus 33 is 27. This 30, negative 30 plus 33 is 3. 27 divided by 3 is 9. So that means that, what does that mean? It means that the elasticity of demand is 9. Okay, so what does that mean? When the price increases 1%, we'll call this, so this is like the A part, the B question. The demand will drop by how much? 9%. That's what he means. So it will 1% increase in price results in a 9% decrease in demand. Not good. So the revenue is going to drop, all right, because we're losing a lot of buyers. So we need to lower that price. Should the price be lowered or raised from 15 to increase revenue? So C, we need to lower the price. Because lowering the price gets us to where we need to be. And let me go ahead and put those answers up here. So the first one, 4P minus 33 minus 2P. So that's what we ended up with. Again, if you distributed the P, you might have a slightly different answer, but this is the reduced answer. The second one, when you plug in the 15, we ended up with 9. 9 is bigger than 1, so it's elastic. The demand's going to drop by 9%, and we need to lower the price. How much? Well, if we needed to answer that question again, remember, we just start with this demand function right here, and we would say E equals 1 and then solve for P. That would tell us the price to maximize. Okay, that is it for 12.6 review. So not too much. take a look at these, look at the homework, and go back through the ones in the practice tests in WebAssign. And I think you'll find all of that very helpful to get this down. Thanks.